Alright, here's another tough problem. What is the units digit of this thing here? We have 3 to the 2011th power minus 2 to the 2011th power. Alright, well, let's just take this a piece at a time. Let's look at what the units digit of this would be, okay, and the units digit of this, okay. I know that doesn't sound any easier, does it? But unless you've seen these before. And then these problems, whenever you're looking for the units digit, it's always a matter of finding a pattern, okay? So let's look at the pattern in the powers of 3, okay? So the first term has 3 to the 2011th, but let's look at 3 to the first power. And the units digit of that is just 3, right? And 3 squared, the units digit is 9. And for 3 cubed, well, 3 cubed is just 27, so the units digit is 7. Now, 3 to the 4th, I know that's 81, because that's 9 times 9, so the units digit is 1. But you could also look at, we're just taking the previous number and multiplying it by 3 once more. And 3 times 7 is 21, so the units digit would have to be a 1 in 3 to the 4th. Okay, so let's keep going. 3 to the 5th is going to be 3. Okay, and you can see that if you add more and more powers of 3, you're just going to repeat this pattern again. Okay, this 3971. Okay, so the units digit is just going to repeat over and over again. 3971, 3971, 3971. And so the key to solving this problem is trying to figure out how many times you're going to repeat that pattern of 3971. Okay, if you do this 2011 times. So let's take 2011 and divide it by 4, because we have 4 elements in our repeating pattern. So if I divide it by 4, okay, we have 5, and which is 20, drop of 1, 0, 1, 2, alright, so that's 8, and we have a remainder of 3. Okay, so what that's telling us is that we're going to repeat this pattern of these 4 units digits 502 complete times plus 3 more. Okay, does that make sense? So where will we end up? We're going to end up on the third one here, which is a 7. Okay, so the first part here is going to end in a 7. Alright, so let's look at now this other part. 2 to the 2011th. Let's look at the powers of 2 just like we did over here. So 2 to the 1 has the units digit of 2. 2 to the 2 squared is the units digit of 4. 2 cubed, 8. 2 to the 4th, okay, that's 16, so I'll just write 6 because that's the units digit. 2 to the 5th is, well, twice this, which would be 12. So that's going to end with a 2, right? So it's actually going to be, 16 times is going to be 32, but anyway, we're only interested in the unit digit, so it's going to be a 2. And if we just continue multiplying by 2, again, we're going to have this pattern repeating. And it's nice that it happens to be a pattern of 4, because we've already divided 2011 by 4, and we said that that pattern would repeat 502 times with a remainder of 3, so we're going to end up here, the third element in the pattern. Okay, so we're going to have something ending in 7, so we have something, this 3 to the 2011, oops, 11, is equal to something that ends in a 7. Okay, and 2 to the 2011 is equal to something ending in 8. Okay, and we're going to subtract those two. Alright, that's what we're looking for. And you can see here that what would we do? We'd have to borrow 1 from a previous number, so we'd end up with 17 here. So we'd have to make this 17, and then when we subtract 8 from it, we'll end up with 9, right? Because 17 minus 8 is 9. And so that's our answer. It's not as hard as you might think. Once you've seen a few of these types of problems, you'll have them down pat. So there you go.